Okay, in this video, we're going to look at finding the derivative of products and quotients. And as mentioned in the previous video, when we had multiple terms adding and subtracting together, we can take the derivatives individually and put all the pieces back. That only works if you have a sum and difference, if I have terms adding and subtracting. If we're multiplying or dividing, I cannot take the derivatives separately and put the pieces back together. So the product rule, if I have two functions that are differentiable functions of x that are multiplying together, so u times v, and I want to take the derivative of that. The way this works out is, you start off, you write the first term, and then you multiply the first term by the derivative of the second. And then you add to it the second term times the derivative of the first. All right, so the way to remember it, first d last plus last d first. And for a lot of these problems, not always, but if they're the product of two polynomial functions or power functions of x, you can always fully multiply it and then take the derivative of the individual pieces if you wanted to. But we're going to do power rule here. So let's look at this first example. We want to find the derivative. I'm going to try to color code here. So I'll have red and I'll have green, all right? And we want to take the derivative. Now the derivative of y is going to be y prime. So I'm going to write y prime is going to equal. The product rule says write the first term. So it'd be 3 plus 4 times the square root of x times the derivative of the second. So it'd be the derivative with respect to x of the second term, 2x squared minus 6. And then plus the second term, so 2x squared minus 6, times the derivative of the first term. So the derivative with respect to x of 3 plus 4 times the square root of x. Now I can see what I'm supposed to take the derivative of, and now we go to work. So I have in my next line, y prime is going to equal, all right, first, 3 plus 4 times square root of x, times the derivative of the second. Well, the derivative of 2x squared minus 6, I can do the power rule. Derivative of 2x squared is 4x. The derivative of 6 as a constant is 0, so I just have 4x for that derivative. Then I keep writing. I have plus, and then we write 2x squared minus 6 times the derivative of the second, or excuse me, times the derivative of 3 plus 4 roots of x. All right, well, here's what we got. The derivative of 3 is 0. Now I want to take the derivative of 4 times the square root of x. Well, I'm going to go down here below it and say, all right, how would I do the derivative of 4 times the square root of x? Well, rewrite the radical as x to the 1/2 power. And then do your power rule. So the derivative of that would be 2 times x to the negative 1/2, which would make 2 divided by the square root of x. So that derivative of 3 plus 4 roots of x is going to become 2 divided by the square root of x. And all we would do from there is we would multiply that out and combine our like terms. And so I work. Now, usually you can leave it like this if it's free response, but if it's multiple choice, chances are they probably will do something with this. And so I could times this out, and I have 12x plus 16 square root of x times x makes x to the 3/2. And then I got plus 4 times x, x squared divided by the square root of x, 2 minus 1/2 is 1/2, so 3 over 2. And then minus 12 over the square root of x. Combine like terms. We'd have 12x plus 20x to the 3/2 minus 12 over square root of x. There's my derivative. All right, let's do it again here. So I want to find the derivative of y, and y is the product of x minus 3 to the 4th power and 2 plus 7x. I want to take the derivative of that. So the derivative of y, with respect to x, I'm going to write y prime. That means the same thing as dy over dx in this case. Is going to be first, so my product rule, write the first part of the product, times the derivative of the second. So I'm writing the d over dx, so what I'm taking the derivative of, 2 plus 7x. So first times derivative of the second plus second, so it'd be 2 plus 7x, times the derivative of the first, so the derivative with respect to x of x minus 3x to the fourth power. Now we do our derivatives. So our derivative of y prime is going to equal, we'd have x minus 3x to the fourth times, now that derivative here, the derivative of 2 plus 7x. The derivative of 2 is 0. The derivative of 7 times x is just 7. So I'd be multiplying that first part there by 7, plus second, so 2 plus 7x, times the derivative of the first, okay, so the derivative of the first part, which is x minus 3x to the fourth power, the derivative of just x is 1, so I have 1, and then the derivative of negative 3x to the fourth, I do power rule, multiply the 4 to the negative 3, that makes negative 12, take 1 away from the exponent, we have x to the third, so minus 12x to the third power. And then we would just multiply this thing out and simplify it as needed, and so I'll do that real quickly here. And we get that polynomial there. There's our derivative. So that is the product rule. Now, let's talk about how we approach the problems when we have a quotient. So if I have two differentiable functions of x, so in this case u and v, and I have u being divided by v, and I want to take the derivative. The way this derivative works is you take the bottom, which is v, times it by the derivative of the top, minus top times the derivative of the bottom all over the bottom squared. So that's what the u's and the v's are representing. And a little saying that helps some people, low d high minus high d low over low low is the quotient rule for derivatives. So let's do some examples here of these two. So I want to find the derivative of f in this case, and f is the quotient of x divided by x squared minus 1. And so what I'm going to do is I'm going to write out my derivative here. So my derivative, I'll have top will be green, bottom will be red. And so the derivative of f prime of x is going to equal bottom, so x squared minus 1, times the derivative of the top, so d over dx of x, minus top times the derivative of the bottom, so times d over dx of x squared minus 1, all over bottom squared. Right? Man. Now let's do our derivatives. So f prime of x is going to equal, and let's see. So I'd have x squared minus 1 times the derivative of x. Now, the derivative of x is just going to be 1, so times 1. And I'd have minus, and we'd have x times the derivative of x squared minus 1. The derivative of x squared minus 1, that'd be 2x minus 0, so I just write 2x, all over the denominator squared. And then we just clean this up as needed. And we don't have to get too crazy with the simplification process because that would all depend upon what our next move was or if we were trying to match an answer choice. So I'd have x squared minus 1 minus 2x squared over, I'd have x squared minus 1 to the second power. And that's basically going to make, we'd have negative x squared minus 1 over x squared minus 1 to the second. There's our derivative of that quotient. Let's do it one more time. So I want to take the derivative of the quotient of 5x squared divided by x to the third plus 1. So the derivative of f here, and I'll color code this again. So I'll let red be the top and I'll let green be the bottom. So our quotient rule is you start with the bottom, x to the third plus 1. So bottom times the derivative of the top. So the derivative with respect to x of 5x to the second power minus the top, 5x squared, times the derivative of the bottom. So the derivative with respect to x of x to the third plus 1 all over the bottom squared. All right, and now we go through and we start applying our derivatives. So the derivative of f is going to equal, all right, it'd still have x to the third plus 1. Now I do the derivative of 5x squared. The derivative of 5x to the second power makes 10 times x. And then I keep writing, so I'd have minus 5x squared times the derivative of x to the third plus 1. Well, the derivative of x to the third, we do power rule. That'd give us 3x squared. The derivative of 1 is 0, so I'm not going to bother writing that. All over the denominator squared, so x to the third plus 1 squared. And now we just simplify it to a point somewhat. And how far we go kind of depends on what our next move is. So my denominator is x to the third plus 1 to the second power. I'm not going to expand that. And we have 10x to the fourth plus 10x minus 15x to the fourth power. And I combine any like terms, and we get our derivative to be negative 5x to the fourth plus 10x all over x to the third plus 1 squared.